We're back to probabilities in this lesson, and we're looking at probability distributions, and that deals with the probability of various different random variables, which are outcomes in a probability experiment. And random variables can be discrete or continuous. So you see here kind of the definition for them, and once you look at them, I hope it kind of breaks down to discrete random variables are your counting numbers. You can count the number of these outcomes, as opposed to continuous, where you're looking at very likely the possibility of decimal values. So in example 1, we're very simply just classifying a random variable as discrete or continuous. So in part A, X represents the time it takes to serve a fast food restaurant customer chosen at random. So it's the amount of time, and time doesn't have to be 1 minute, 2 minutes, 3 minutes. It can be 1.5, so on and so forth. So there's infinite breakdowns of time. So for part A, this is continuous. In part B, it represents the attendance at a randomly selected monthly school board meeting. So we're talking about people, and we can't have 1.5 people at a meeting. So this is discrete. These are counting numbers. When we're looking at a probability distribution, we're looking at a table, or mostly in our lesson, we're looking at a table and a graph that links each possible value of X with its probability of occurring. So a couple of things that you need to remember is that the probability of each event has to be between 0 and 1. We've talked about how that is the range of possible values for any probability. And when we're talking about a probability distribution, the sum of all of those probabilities has to equal 1. So let's construct a probability distribution. This car salesperson tallied up how many cars she sold on any given day, and she sold 0 cars on 20 days, she sold 1 car on 7 days, she sold 2 cars on 2 days, and 3 cars on 1 day. We're going to use this frequency distribution to construct our probability distribution. So cars sold is X. And the probability of X is, well, there were 30 total days, so 20 out of 30. Probability that 1 car was sold, that's 7 out of 30. Probability that 2 cars were sold, that's 2 out of 30. And the probability that 3 cars were sold is 1 out of 30. And if I were to add all these probabilities together, they all have a common denominator of 30. So 20 plus 7 plus 2 plus 1, well, that's 30 over 30. So the sum is 1. So this is a table representing my probability distribution. Let's also graph it. And let's express these as decimals. That makes it easier to graph. 20 over 30 is 0.6 repeating. 7 over 30 is 0.23 repeating. This is 0.06 repeating. And 0.03 repeating. So that just makes it easier for us to graph. So the highest my probabilities go is 0.6 repeating, so I'm going to go up by 0.10. And the probability that 0 cars were sold is 0.6 repeating, so I'm going to make that about here. Probability that 1 car was sold is 0.23, so about here. probability that 2 cars were sold was 0.06, so about here. And the probability that 3 cars were sold, half of that, so right there. And there we have constructed a probability distribution and displayed the information in a table and in a graph. Now, in the previous lesson, we saw, and we remembered, that calculating the mean of a statistical group of data involves adding everything together and then dividing by the number of terms. We don't do that when we're finding the mean of a probability distribution. In order to find the mean of a probability distribution, we're still finding a sum, as you see here by this sigma notation. But what we're finding the sum of is the product of each random variable with the probability of that random variable occurring. So in example 3, they're asking us to find the mean of the probability distribution that we constructed back here. Okay, so that means, let's just redo that table. So my x, my probability of x, and then I'm going to be multiplying x times the probability of x. And then at the end, I'm going to find the sum of all these x times px's. 0, 1, 2, 3. And the probability of 0 was 0.6 repeating. Probability of 1 was 0.23 repeating. Probability of 2 was 0.06 repeating. And the probability of 3 was 0.03 repeating. Once again, all I'm doing is taking this information and just copying it back down. So now when I multiply, I've got 0, 0.23 repeating, 0.06 repeating times 2 is 0.13 repeating. 0.03 repeating times 3 is 0.09 repeating. I'm going to add all this together in order to find my mu, which will end up being that's 0.46 repeating. So the problem wanted us to find the mean and interpret its meaning, okay? So on average, she will sell half a car. What? That doesn't make any sense. So on average, she sells a car maybe every other day. Okay, so every 2 days, she sells a car, approximately. Once again, we have variance and standard deviation in probability, just like we have it in statistics. However, the formula is very different. So remember that in statistics, the variance was what we could calculate pencil and paper, and we did that by first finding the mean, the mu, and then subtracting it from each term. So you see kind of that showing up in this formula as well. And we squared it. And this time, instead of adding them all together and dividing by the number of terms, we're multiplying by the probability of each of those events and then adding all those together. So once again, a table in order to keep our information organized would probably be helpful. So I'm going to once again take the information from this problem and copy it on over here. taken the information from the previous one. Now my table is going to change a little bit because I'm going to figure out what x minus mu is squared, and then I'm going to figure out what x minus mu squared times p of x is. And then finally, I'm going to take the sum of everything in this column. So I'm going to take the sum of all of my x minus mu squareds times px's. Okay, so remember that our mu, we found that back here, was 0.46 repeating. So, in my calculator, 0 minus 0.46 squared, that's 0.217 repeating. 1 minus 0.46 repeating squared, 0.284 repeating. 2 minus 0.46 repeating squared, that's 2.351 repeating. And 3 minus 0.46 repeating squared is 6.417 repeating. And now for my last column in the table, for my last trick, for my next column, I'm multiplying these two values together. And then I'm going to add them all together. So, 0.217 times 0.6, 0.145. And be as precise as you can. 0.284 repeating times 0.23 repeating, that's 0.066. 2.351 repeating times 0.06 repeating, that's 0.157. 0.03 repeating times 6.417 repeating, 0.214. Now adding everything in this column, we have that our variance is 0.582, and our standard deviation is the square root of that, so 0.763. Finally, the last kind of problem that we're looking at in this lesson is finding an expected value. So I like this example. At a raffle, 500 tickets are sold at $1 each. There are 3 prizes. One for $100, one for $50, and one for $10. So what is the expected value of your net gain if you buy a ticket? So let's talk about the different things that can happen. Let's talk about the possible winnings you can have. And that'll be my X. You could win $100, which actually means that you're gaining $99. You could win $50, but you paid $1 for that ticket, so it means you're actually winning $49. You could win $10 that you spent $1 on the raffle ticket for, so you're actually winning $9. Or which I'm sure you realize is more likely, you could not win anything, which means you just lost $1. Okay, so the probability of each of these events, well, there's 500 tickets sold, and only one of them is going to win $100. Only one of them is going to win $50. Only one of them is going to win $10, as opposed to 497 of them winning nothing. So what is the expected value of our net gain? Well, we're calculating the mean. So that means we're multiplying this x times the probability of it occurring plus this x times its probability times this x plus its probability times this x plus its probability. So I'm going to just put the sum here of x times px, and 99 times 1 over 500 is 0.198. 49 times 1 over 500 is 0.098. 9 times 1 over 500 is 0.018. And -1 times 497 over 500 is negative 0.994. And when I add these all together, actually I should have given myself a little more space over here. That is negative 0.68. So what that means is the average person is losing 68 cents every time they buy a ticket. In this problem, we're talking about a water park that makes $350,000 when the weather is normal, but loses $80,000 when there's more bad weather days than normal. So the probability of having more bad weather days than normal this season is 35%. We're asked to find the park's expected profit. Okay, so there's two different things that can happen. They can make money, or they can lose money. And the probability that they make money, since the probability that they'll have bad weather is 35%, that means probability of mostly good weather is 65%. So we're going to multiply these together. So 0.65 times 350,000. Oops, too many zeros there. And I'm multiplying these values. Negative. So the expected profit is what I find when I add these two numbers together. Which is $199,500.